Assalamu alaikum. Hope you are doing fine. The height of nearby objects such as tree or tall tower can be measured with the help of a triangulation method. But we cannot use this method to measure the distance between Earth and the Moon. And as well, if you want to measure the distance between Earth and the planet, then this method cannot be used. We go for another method such as the Parallax method and the radar method. In this video, we are going to discuss about these two methods. Let's get into the video. First, I'll tell you what is the parallax method. Parallax method. Before I'll tell you what is parallax method, let me tell you what is parallax. Parallax is nothing but the apparent change in the position of an object with respect to the background when the object is seen from two different places. Here, the distance between those two places from where we look at the object is known as base. Suppose I hold this chalk piece in my hand with the wall at the background and I look at this using my right eye by closing the left eye. Then I look at this chalk piece using my left eye by closing the right eye. Then the position of the chalk piece appears to be changing when it is seen from two different eyes. This apparent change in the position of the chalk piece is referred as parallax. So let me explain this to you with the help of a diagram. Here is the diagram. Now, I have observed is represented letter O and the position of the object when viewed using right eye is here, and the position of the object when viewed using left eye is here. Now the distance between these two, that is left eye and right eye, is taken as base here, and it is represented by letter B. Here the distance between right eye and left eye is taken as B, and the angle between these two lines, that is LO and RO, is taken as theta. This angle theta is referred as parallax angle. Now I name this length LO as X, and here RO is also of the same length, so it is denoted by the same letter X. Let me repeat this thing. Here O is the observer and L is the position of the object when seen from left eye, and R represents the position of the object when seen from right eye. Or in simple words, here L stands for left eye and R stands for right eye. The distance between these two is taken as base. Now, if you look at this, the line which connects L and R appears almost to be equal to an arc. So, from this diagram, we get this expression. Plane angle. What is, the expression for a plane angle is the ratio of arc length. Here I take this as the arc length divided by radius. In our case, this is the radius. So plane angle, which is usually represented by letter theta, equal to arc length. What is that? It is b. And the radius here in our case is x. So the expression for parallax angle theta is obtained from this equation. Now if you want to know x value, then what you need to do is you need to take x this side and theta will come to the place of x, and easily you can able to find out the value of x, which is the distance, approximate distance between the observer and the object. Now I will use this parallax method to determine the distance of moon from earth. So, determination of let me write this one here. Determination of distance of moon from earth. Now I consider a point here. I denote this by letter M. This point represents moon. Then moon is viewed from two different places from the surface of earth. Now I draw this circle which represents earth. Then see, this is the diameter of earth with the with C as the center of earth. Now I choose 2 points A and B. Here point A and point B are 2 places on the surface of earth which are diametrically opposite to each other. Now I connect A and B to M. See? To do that, I do the same thing to this point as well. Now I connected this. Then I'll find the parallax angle of a moon with respect to a distant star. To do that, I consider one star here as S1. It is star S1. With respect to star S1, the parallax angle of moon is measured as theta 1 with the help of an astronomical telescope. Then I'll measure one more angle, theta 2, which is another, for convenience I color these 2 points using orange. Now with respect to another star S2, I measure parallax angle at theta 2 using telescope again. Now the total parallax angle extended by moon is represented as a theta, which is obtained by adding these two parallax angles. So here theta, which is parallax angle, is obtained if we add theta 1 and theta 2. I hope I understood. And here in the diagram, as I told you earlier, by comparing this with the previous diagram, the distance between these two places on the surface of Earth is referred as base. So here AB is nothing but B. Here B stands for base. Then I use this equation. You see, from here theta is equal to B upon x. So what is B here? B is AB. B is AB. And what about x? Here x is actually any one of these two lines. It is either AM or BM. I take AM. This is x. Understood. Here I can write it like this. Here AM is equal to BM, which is again equal to x. Now I do a small modification to this. Here I take another, I draw a line that connects C and M. You see? Yeah, this line. This gives actual distance between the center of Earth and center of Moon. This is the actual distance between Earth and Moon. Now I say that in this equation, AM is approximately equals to distance MC. So which is nothing but the distance between Earth and the Moon. So I am going to replace AM with MC. From here, what do I get? I get this. Theta is written as AB upon MC. Now I will substitute the values of AB and MC. Here I take we know AB is nothing but small b, and what is MC? MC is the distance between Earth and the Moon. So it is taken as when AM is equal to x, then MC will also be equal to x, approximately equal to x. I repeat, when AM is equal to x, then MC will be approximately equal to x. So I write x in the place of MC. So here this equation is written this way. Theta is equal to B upon x. This is the expression for parallax angle. Now my aim is to find the value of x. So what I do a small modification to this equation. I take x to the left hand side and theta is taken to the right hand side. If I do so, I get this equation. X is equals to b upon theta. This is the final expression which gives the distance between Earth and Moon. Why do I measure the distance between Moon and Earth from the center? You always remember this. If you are asked to find the distance between two spheres, then we always measure it from their center. So, distance is measured from their center like this. Suppose if you measure the distance from this end to this end, it is wrong. Again, if you measure the distance from this end to this end, again it is wrong. We always measure the distance between two spheres from their center. Here Earth is spherical in shape, almost spherical in shape, and the Moon is also almost spherical in shape. So the distance between them is measured from their center. I hope you have understood. This one can easily find the distance between Earth and the Moon. And in the place of this, if we have some other planet, the same method is followed to measure the distance of that planet from Earth. Now let me tell you what is the radar method. Radar method. Here, radar stands for radio detection and ranging. The word has come from these letters taken from this sentence. Radar method is used to measure the distance between Earth and a nearby planet. What is done here? We send radio waves towards the planet, and the reflected wave is received. Here, the time is measured for transmission and reception of radio waves, and usually the distance travelled by the radio wave will be twice the distance between Earth and that particular planet. So here, the distance covered by the radio wave is taken as twice the distance between Earth and the planet, and time taken there is taken as t. Now, the moment the wave is transmitted from the transmitter, we start the stopwatch. When it is received at the receiver, the stopwatch is stopped. This is how the time t is measured. Then from these two, we have this, the expression for speed. Speed is the ratio of distance and the time. We know the value of distance, it is 2d. And here I represent the speed by letter v, and the distance is 2d, and the time is represented t. Now my aim is to find the value of d. So I do a small modification to this. I take a t this side, so it will multiply, and here 2d will remain as such. Then d is kept as such, 2 is taken this side, so it will divide. We get this equation. Now I rearrange this equation. Write it like this: v into t divided by 2. This is the final expression which gives us the distance between Earth and the planet. Now if you know the value of v and t, By substituting them in this equation, you will get D. Radar method is also used to measure the distance of a flying object. Suppose there is an aircraft flying nearby and you want to measure its distance. So in that case, what is done? A powerful beam of radio wave is transmitted from the transmitter. Then when it hits the aircraft, it gets reflected. It is received again. Here, the antenna used in radar is duplexer antenna. It behaves as a transmitter as well as a receiver. So the total distance traveled by the radio wave is a 2D and the time taken is measured as a T. By substituting these values in the above equation, one can easily get the distance at which the aircraft is flying. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.